This is the Autoparametric Resonance 3 Motions Machine, or Frantic Wasalulia for short. That's the name Tinkercad gave it. And it's this mass on a spring attached to this table I made when I was a 9th grader. And of course, the spring can spring up and down. It can swing side to side, and this thing can twist, and you see the arms. But the cool thing about this is that when I let it do one of those, it naturally wants to start doing one of the others. Or both. That was bouncing. Here's swinging. And here is twisting. Now, like I said in the name, the way this happens is through autoparametric resonance. And this may be similar to a device you've seen before because it's famous. That is Lionel Robert Wilberforce's pendulum, which bounces up and down and twists. And the way it does that is it's bouncing, but then as it goes down, the spring naturally wants to kind of uncurl to let it go farther down and extend, and that causes it to twist. And as it comes back up, the spring contracts and twists the other way. And so it's adjusting its own parameters and, well, causing it to change motions. Now, this other one, which I originally saw from Steve Mould, oscillated between swinging and bouncing. And so as it would swing, it might happen to go down a bit, and then up and down, and then soon enough it was over to bouncing, and if it was bouncing and it happened to be a little bit off to the side, then it would be bounced up to the other side, and then come down and bounce to the other side, and sure enough it was swinging. So I combined these both into this machine. It is held together by clear sticky tape. I made my spring out of polylactic acid on the Creality Slicer's default settings for fast printing. However, 3D printed springs can be a bit finicky, so here's how to calibrate it. You want twice the swinging frequency to be equal to the bouncing frequency, which should be about equal to the twisting frequency. And here's my helpful chart of what to adjust to calibrate what. And the parts in red are what I think are the easier option to calibrate. So for swinging, you want to calibrate the length from the top of the pendulum to the center of mass. And you can do this by bunching up the spring when you tape it to the top. For the bouncing, you want to calibrate the mass, and that can be printing this weight with different infill or a different size. And then for twisting, you want to calibrate the moment of inertia, and that's a quantity that tells you how hard is it to rotate a thing or to stop it from rotating. And it's dependent on both mass and how far that mass is from the center of the object. And so to adjust that, you can take your slicer and change the dimensions for the X and Y and change them relative to the Z. And so it'll have the same mass but different moment of inertia. Just when I thought I was done and was starting to take this apart, I remembered what Steve Mould said about the Lego minifigures, so here goes. Sure looks fun to me. And this requires a lot of screwing around the spring to get the Lego minifigure in and out.